It was a neat opportunity to actually engage in collegiate level research and work with people who are doing cutting edge work. Also the idea of applying what's going on in a college into your classroom and showing kids and letting students experience that so they can see what's possible for them in the university realm. A lot of them view universities as lecture halls and more homework than they've ever seen in their life. And if you can show them that there's an experimental side, that there's a side where they can actually discover something for themselves that's new, I think.
Well, I'm going to start out by giving my students some instruction on electricity, and what they'll be doing is actually designing a charger for their iPod out of different electrochemical cells, perhaps even a mechanical generator. Then we'll also look at how energy is used inside the home and how energy can be conserved.
Just bringing the real world to the classroom, especially in a math classroom. Sometimes they don't see the connections between what they're doing in a book and what happens in the real world. So anything that we can do that brings the real world into the classroom, anything that we can do that puts their hands on something real makes a difference.
The success that I had last year with the legacy cycle in the classroom made me want to come back to get another legacy cycle. I saw just a huge increase in the student engagement and the students' readiness and willingness to jump out on a limb and take risks in the classroom, to think for themselves, to get their hands dirty in the lab. I just saw such an improvement across the board in the quality of student, and I don't think that was due to chance. I think that was due to starting the year with a successful legacy cycle.
This is my first year teaching.
Oh.
So I spent 20 years in industry.
Wow.
So one of the things I struggled with as a first year teacher is I had students say, well, when will I ever use this? Well, I had examples, but I didn't have a good way to integrate it in the classroom. So the legacy cycle, I came to learn how to do that. And it's been wonderful as a way to how do you bring the outside in a format, and I expect to do it more than just this one, but this is one that starts. As far as resources, you know, we are a small county. It's rural, and this is an opportunity for us to get some things that we wouldn't get and some experience. For one thing, at the STEM Center, learning what's here, what resources we can come here and draw on and really help our kids get a broader experience is great.
It was such a wonderful experience the first time because it really changed the way that I taught. I do a lot of my class as research-based, design-based. I do all my physics that way, and I'm trying to do my chemistry that way now. And so last time I worked on a physics project, and this year I'm working on a chemistry project.
I had our assistant superintendent of professional development sent me an email about this program, and I read about it, and it sounded so unique. I thought it was a great opportunity to get some experience at Tech and with research.
The program is a lot more structured this year than it was last year, and I think that that's been a big benefit to the teachers. We've really had a plan laid out for us more than struggling to find our way. And so I think that the program has improved for the better, and I would encourage anybody that's considering applying to the RET program to definitely do so.